Hello everybody, in this lecture we are going to talk about variables. First of all, we must know that Solidity is a statically typed programming language. That means that for every variable we define, we must specify its type. This is in contrast with other programming languages like PHP or Python, where the variable type is deduced at runtime. This is not valid in Solidity. We must specify its type at declaration. Okay, then we have two types of variables. We have state variables and local variables. State variables are permanently stored in contract storage. Storage is not dynamically allocated. What does it mean? Let's take an example. I have a simple contract here named property, and I'm going to declare a state variable. Let's say a string variable, this is the variable type, which is mandatory to be specified. After that, optionally, we can specify its visibility, for example, public. We'll talk more about the visibility of variables and functions in another chapter. So, string public location. This is a storage variable. Let's declare another storage variable. For example, int public, the same visibility, and let's say price. We have two storage variables. If I deploy this contract will have only two state variables. There is no possibility, let's say, to add another variable, to say, okay, I want this contract to have another variable named owner. It's not possible. All variables must be defined before deployment. This is what it means when I say storage is not dynamically allocated. Okay? Then, they must be declared at contract level. This is contract level. After the name of the contract, we declare the state variables for this contract. They must be initialized at declaration using a constructor or after contract deployment by calling setter functions. For example, if I want to modify the value of the location variable, let's say location equals London. This is not permitted in Solidity. As you can see, there is an error. This is not permitted. I can't define the variable after its declaration. This is possible in other programming languages like Python, for example. Here, this is not allowed. What can I do? So, first of all, I write this is not permitted in Solidity. If I want to modify the value of this variable, I can create a special function named setter. For example, function set property. This function must have at least one argument, let's say a string argument named underline location. This is another variable. This is why I call it underline location. Public. Public means that this function can be called from another application from outside of this contract. For example, I can have a web application that calls this function. This means public. And now location equals underline location. When this function will be called, of course, having one argument, this function will modify my storage variable named location. This is one possibility to modify a storage variable. Okay? Another possibility is to specify the value of the variable at declaration time. For example, I can say here, I can write location equals Paris. Let's try to deploy this contract by pressing on deploy button. I've deployed the contract using the in-memory blockchain. Okay, my contract received an address, and now I have my two variables, location and price. Location equals Paris, because when I declared the variable, I specified the value of string Paris, and price has the value of 0. An integer variable is automatically initialized with 0 if I don't specify another value, of course. If I want to modify the value of location variable, I can simply call this function. Here I have a button, yeah, set property, and I can write here, let's say Amsterdam. Okay, and now location. The new location is Amsterdam. So my function, my setter function, modified the variable. Let's come back here. We'll have another lecture about constructors, so we'll discuss more then. They are expensive to be used. They cost gas. Okay, what does it mean? It means that this variable will be saved on the Ethereum blockchain. If we save this variable on the Ethereum blockchain, we must pay for it. Yeah? So this variable costs gas. This variable costs also gas. So all storage variables cost gas because they are saved on the Ethereum blockchain. What is a local variable? A local variable is declared at function level. What does it mean? For example, inside this function, I can create another variable. Let's say simply int a. This is a local variable because it's declared inside the function. Then, if using the memory keyword and the local variable is an array or a struct, they are allocated at runtime. Memory keyword can be used at contract level. I want to explain a little bit more here. Let's create a new variable, a dynamic array variable of type integer. So int, let's say simply x. Okay? My x variable is a dynamic array. Being a dynamic array, it will automatically be saved on storage, like location and like price, because dynamic and fixed arrays, struct and mappings are all saved in storage. If I use the memory keyword here, this variable, even if it's a dynamic array, will be allocated at runtime and it will be allocated in memory. Okay? This is what this keyword does. Then let's see where does the Ethereum virtual machine save data. The Ethereum virtual machine has three areas where it saves data. It has storage, memory, and stack. Storage is where state variables are saved. Storage is persistent and expensive. It's like a computer hard drive. For example, if I deploy this contract on the Ethereum blockchain, the value of this variable will be there forever. In the future, if I call this function, getLocation, or simply location, because the variable is public, I will get the value of this variable. This means persistent. Expensive because, as I have already said, it costs gas. Another area where Ethereum virtual machine holds data is memory. There we find temporary values. It's free to be used and it doesn't cost gas. It's like a computer RAM memory. And then we have the stack. It holds function variables and it's free to be used. Let's come to a conclusion. First, state variables are always saved in storage. Function arguments, for example, underline location is a function argument. Function arguments are local and are stored in memory. Then variables defined inside functions are saved in storage if they are struct, array, or mappings, or they are saved on the stack if they are of any other type, like example an integer. Let's clarify this. I erase this keyword. So this is a dynamic array. Being a dynamic array, this is saved in storage. This is an integer variable. Being an integer variable means that this variable will be saved on the stack. So saved on the stack. Okay? These variables are local. So I write here local variable. And the location, this variable is also a local variable and is saved in memory. I can comment here, underline location is local and saved in memory. Let's delete this contract deployment. I deploy the contract one more time. So location is initialized with value of string Paris. Price is automatically initialized with 0. And if I want to modify the value of location, I can simply call this function. I called the function and now the new location is Madrid. If I want to modify the value of variable named price, I can't do it. There is no possibility because the interface doesn't have such a method, such a function. There is no function like setPrice. So price can't be modified by anyone after the contract is deployed.